This video is on factored versus standard form of quadratics. We're going to do some examples of rewriting into the form specified. Then we're going to determine the x-intercept or x-intercepts, the y-intercept, and if it is a maximum or minimum for each of the problems. The first question asks us to write it into standard form, which means that the original should be in factored form already. We have two linear factors multiplied to each other, so this is in factored form. Before we even begin working on standard form, we can look at the original problem to determine what it already gives us. Since it is in factored form, it gives us our x-intercepts automatically. So to find our x-intercepts, we take the individual factors, our linear factors, and we set them equal to 0. So we have x plus 2 equals to 0. We solve this by subtracting 2, and we have x equals negative 2. That is one of our solutions, which means that it'll be one of our roots, one of our zeros, and we can write it as an x-intercept. Our other linear factor of x plus 6, we set equal to 0. We subtract 6 from both sides, and we have x equals negative 6. So we will be able to write out our x-intercepts from this. Next, because we need to find our y-intercept, we need to put this into standard form to find our constant. So we take our factors and we distribute them into each other. So we take all of this first factor and multiply it into our second factor. So we take our x and multiply it to our x and to our positive 6. X times x is x squared, and x times positive 6 is positive 6x. Since we're distributing through the parentheses, we are able to get rid of the parentheses. But we still need to multiply this positive 2. So we take our positive 2 and multiply it to the x and to the positive 6 because we're going from one parentheses into the other. So we have positive 2 times x is a positive 2x, and a positive 2 times a positive 6 is a positive 12. Now we are able to combine our like terms, and we still have it as y equals. So our standard form becomes y equals, nothing combines with x squared, 6x plus 2x becomes 8x, so a positive 8x, and nothing combines with our 12, so we have plus 12. This is our standard form. Then we can find our x-intercepts, which we found from our factor form earlier, which are at, so the x-intercepts are at negative 2, comma 0, and negative 6, comma 0, because it's the coordinate of the x-intercept when the y value is 0. The y-intercept comes from our constant of standard form, our c value, which is 12. So our y-intercept is when the x value is 0, and we put 0, comma 12. Y-intercept is when the x is 0. We can still need to determine if it's a minimum or a maximum. So we can look at either the original problem or our new standard form. The original problem has a positive in the front, and so does our standard form, which should happen. So we have a positive a value, which means that it opens up, which means that this will be a minimum. So we have y equals x squared plus 8x plus 12. We have the x-intercepts at negative 2, 0 and negative 6, 0. A y-intercept at 0, 12, and the fact that we have a minimum vertex. So if we look at this next problem, also putting it into standard form, we can go ahead and look to see what our x-intercepts are because it should be in factored form. If we want to put it into standard form, it should be in factored form right now. So that means that our x-intercepts come from our two factors, our linear factors of x plus 1. So x will equal to negative 1 because we're subtract 1. And it comes from the other linear factor of x minus 1 equals 0. So we'll have x is equal to a positive 1 because we add 1 to both sides. Now we need to be able to put this into standard form by distributing everything to get no parentheses. So the first thing you can distribute the 3 into the first set of parentheses so that you no longer see it on the outside. And that's what I'll do first. I will multiply this 3 to inside this first set of parentheses. So we'll have parentheses 3 times x is 3x, and 3 times 1 is positive 3. But I still keep the other set of parentheses that I have not multiplied into yet. Now we distribute the first set of parentheses into the second set. I could have done this earlier and then distributed the 3 later, which would have been perfectly acceptable as well. So I'll take the 3x and multiply it into everything into the second set of parentheses. So I have positive 3x times positive x is positive 3x squared, and positive 3x times negative 1 is a negative 3x. Then I'll multiply the positive 3 to everything in the other set. So I'll end up with a positive 3 times x is positive 3x, and a positive 3 times negative 1 is a negative 3. I still have all of this as a y equals, so I'll put y equals on here. Now I want to combine my like terms. Since I have no more parentheses, I just need to combine like terms to put it into standard form. So we'll have y equals, nothing combines with 3x squared, so we have 3x squared. Negative 3x plus 3x is 0x, so that means that it is gone. These eliminate each other, become 0, so I do not put any x in here. But then I have minus 3, so I'll put minus 3. This is now in standard form. And that is okay if that happens, that the middle term, the b value, becomes 0. That is perfectly acceptable. Now that we've rewritten it, we can write out all of the information. So the x-intercepts came from our factored form from the beginning, which was at negative 1, 0, and at positive 1, 0. Our y-intercept comes from our constant, which is at a negative 3. So our y-intercept is 0, negative 3. And we can determine if it's a minimum or maximum. Again, we can base it off of the first value from the factored form, which is a positive 3, and our a value from our standard form is also a positive 3. Since it is a positive, we know this graph will open up, which means it is a minimum. So we have y equals 3x squared minus 3. Our x-intercepts are at negative 1, 0, and 1, 0. Our y-intercept is at 0, negative 3, and this is a minimum graph. It has a minimum. So these next two examples are asking us to write it into factored form. So we'll put this into factored form and still find all the information. The first thing you can actually determine is that this graph has a y-intercept. Since it is already in standard form, we can look at the original and determine what our y-intercept is, which is nice. So the first step in factoring is to do your GCF. So we're going to write out GCF. Our smallest number on this problem, we have 15, a negative 8, and a 1. So the smallest number is a 1. Our GCF, therefore, has to be a 1. All terms do not have the variable x, so our GCF is just 1. That means that we do not have to divide anything. Now I'll just use guess and check to determine our factors. So I'll take my x squared, and I know that's going to be x times x. Then I'll take my 15, which is 1 and 15, and then 3 and 5. Then I will guess to see which numbers go together, and then I'll check to see if they work. So I'll have two sets of parentheses. I will put x and x into the front, because I know that x times x gives us x squared. And then I will try my 3 and my 5 in the back, because I know that 3 times 5 gives us 15. Now I'm going to check. 3x and 5x. So I have 3 times x is 3x, and x times 5 is 5x. I need that to give me an 8x, which 3 and 5 can if I have them both negative. So negative 3 and negative 5 will add to a negative 8, but I have to check to make sure they will still multiply to a positive 15. Negative 3 times a negative 5 will give us a positive 15. That means that both of these should be negative. I have now checked, so I know that my factors are correct, and my GCF was 1, so I have the 1 on the outside. So to put this into factored form, we'd have y equals, parentheses, x minus 3, parentheses, parentheses, x minus 5. This is now in factored form. Because it's in factored form, I can now find my two x-intercepts. So I'll take my x minus 3 and set it equal to 0. I'll have x equals positive 3. Then I'll also take my x minus 5, set it equal to 0, and have x equals positive 5. So our x-intercepts are at 3, 0 and 5, 0. The y-intercept actually came from the original problem, the standard form. It was our constant at 15. So our y-intercept is at 0, 15. I could have written that out before I did any of the math. I can also determine if this is a minimum or maximum from the original because our a value of positive 1 is positive, therefore it is a minimum. So we can rewrite it into y equals x minus 3 times x minus 5. Our x-intercepts are at 3, 0 and 5, 0. Our y-intercept is at 0, 15, and this would have a minimum. Our next problem, it asks us to rewrite into factored form. So again, this should be in standard form already. There are no parentheses, and it goes in descending order. The exponents go in descending order, so 2, 1, no exponent. That means we can find, since it's standard form, this should give us our y-intercept, and we could go ahead and write it down, but I'm going to wait to see how much room this takes. So to put this into factored form, first step is to find your GCF. Our smallest number, so we have a negative 20, a 1x, and a 1x squared. So our GCF, the smaller number, is 1. And again, I'm just looking at the value of it, the absolute value of it, not the fact that this is a negative 20. All of these terms do not have an x, so the GCF is just 1. Therefore, I do not have to divide by 1. I can just go ahead and go into guess and check because there are 3 terms. So I'll take my x squared, find the factors of those, which are x times x. I'll take my factors of 20, and I'll only use the 20, not the negative, but I just know that it is a negative when I multiply it out. So I'll take 20. I know that's 1 times 20, 2 times 10, and 4 times 5. So now I'm going to guess which numbers go together, and then I'll check. So I have my 2 sets of parentheses. My GCF is on the outside, it's a 1. I'll put x and x in the front of both because I know that x times x gives me x squared. And then I'll check I'll start with 4 and 5. I'll put 4 and 5 because I know that 4 times 5 does give me 20. And then we will check. 4 times x is 4x, and x times 5 is 5x. I need 4x and 5x to give me a 1x. That can happen if I subtract my 4x. 5x minus 4x gives me 1x, so that checks, but I have to make sure it still multiplies. Negative 4 times positive 5 gives me negative 20. So that means that if I put the signs in the correct spot, so my 4 and x gave me the negative, so I need to make my 4 negative. My x and 5 need to both be positive to keep it positive 5x. So again, I'm going to check. 5 minus 4 gives me 1, and negative 4 times positive 5 gives me a negative 20. So I have now checked it. It does factor, and these are my 2 factors. So I will rewrite this into factored form of y equals, so my GCF was 1, so there's really a 1 out here, of linear factor of x minus 4 times x plus 5. This is now in factored form. Because it's in factored form, I take my 2 linear factors of x minus 4, set it equal to 0. We get x equals positive 4. My x plus 5, set that equal to 0. We get x equals negative 5. Now that we have the solutions, we can put those as our x-intercepts. Those x-intercepts are at 4, 0 and at negative 5, 0. The y-intercept, again, came from the original standard form, that negative 20. So now that I knew how much room there it took, I can now put in 0, negative 20. And I want to look at my a value from the original of a positive 1 and my factored form, which is still a positive. That means it opens up. Therefore, it is a minimum. So y equals x minus 4 times x plus 5. The x-intercept's at 4, 0 and negative 5, 0. The y-intercept is 0, negative 20. And it has a minimum vertex.